home. We are continuing on with worksheet 2-3, and we're on number, you guys said we're on 53 now. We're on question number 53. It's 53. So more of the same type problem we were doing Tuesday. 53 on worksheet 2-3. Again, they tell us, they give you information, they say secant is 2. This looks like a tougher one. Secant of theta is 2. Well, if they tell you secant is 2, we should know one of the other ones right now. If secant is 2 over 1, cosine is 1 over 2. Cosine is 1/2, okay? So they didn't tell us that, but we know it because we know the reciprocal of secant is cosine. So cosine is positive 1/2. Cosine is positive, so it's either got to be in quadrant 1 or quadrant 4. They tell us, where are we at? Sine is less than 0. Sine is negative, okay? So if sine is negative, it's going to be down somewhere. It's going to be down, and if cosine is positive, it's going to be to the right. So we're going to be in quadrant 4. So we draw our reference triangle in quadrant 4, connected to the x-axis, not to the y-axis. Okay, you always connect to the x-axis. And our reference angle is theta right there, coming out of 0, 0. Cosine is adjacent over hypotenuse, so adjacent is 1, hypotenuse is 2. We got to find out what the third side is. So we use the Pythagorean theorem, and again, you don't automatically plug in the two numbers they give you for a and b. In this case, a and b are 1 and x. It's two sides that make up the right angle. So x squared plus 1 squared equals 2 squared. X squared plus 1 equals 4. Subtract 1 to each side, x squared is 3. So we square root each side. X equals plus or minus radical 3. Okay. And which is it, plus radical 3 or minus radical 3? Minus, because it's down. Negative radical 3. And make sure you put negative radical 3. Don't put radical negative 3. That's not the same number. That's an imaginary number, okay, which exists, but it's not a real number. So let's write everything out. Sine of theta, cosine of theta, tangent of theta, cotangent, secant, and cosecant. And what is, we already knew cosine was 1/2 and secant was 2. Told us that. Okay. And then sine is opposite over hypotenuse, negative radical 3 over 2. Tangent is opposite over adjacent, so negative radical 3 over 1, which is negative radical 3. Reciprocal of negative radical 3 is negative radical 3 over 3. And cosecant, if you flip negative radical 3 over 2, you have negative 2 over radical 3 times radical 3, you have negative 2 radical 3 over 3. We actually could have used a unit circle on this one. I mean, as soon as we knew that cosine was positive 1/2, if you use your unit circle, that would have been, what would that have been, at 300 degrees, I think it would be? If you look at 300, that would have given you the stuff. It was down here at 300 degrees, cosine is 1/2, like they said it was. So you could have used unit circle, I didn't have to use unit circle though. Okay, two more like that, 55 and 57. 55. They tell us the tangent of theta is 3/4. Okay, tangent is positive. Well, tangent is positive in the upper right, quadrant 1, and the bottom left, quadrant 3. But they're telling us sine is negative. Sine is negative down, so it's got to be in quadrant 3. Okay. Again, since tangent's positive, it's either in 1 or 3. Sine is negative in 3 and 4, so it's got to be in quadrant 3. Okay, tangent is opposite over adjacent. Opposite is 3. Adjacent is 4. So we have a 3, 4, 5. That's wrong, by the way. It is a 3, 4, 5. Okay, so it's, what should be negative? 3 and 4. Now is that going to, I thought but tangent's supposed to be positive 3/4. Well, a positive 3 divided by a negative 3 divided by negative 4 is a positive 3/4. Okay? And the 5 is not negative because the hypotenuse is always positive. Okay? All right, this should be a nice one then. So we have no radicals, sine, cosine, and tangent. Sine is opposite, negative 3 over hypotenuse, which is 5. Cosine is adjacent, negative 4 over hypotenuse, which is 5. Tangent we already knew was 3/4. And then to find cotangent, secant, and cosecant, you flip all of them. Cotangent, secant, and cosecant. So negative 5/3 for cosecant, negative 5/4 for secant, and 4/3 for cotangent. Hopefully it feels like we're doing the same problem over and over and over again, which we basically are, just different situations. One more of these, then we have to talk about something new. Okay. 57. Also, in case anybody's curious, I think we're probably going to have a homework quiz over this probably next Friday, a week from tomorrow, because we still have, tomorrow and probably Tuesday to work on it with you guys. Then I'll probably have Thursday be a work day, and then Friday we'll have the homework quiz. Is what I'm thinking. That's what I'm thinking. Okay. The earliest we'll do it is next Thursday, but probably next Friday. Okay, so tangent is negative 1/3. Okay, so tangent is negative. Tangent is negative in quadrants 2 and 4. Okay, and they're telling us that sine is bigger than 0. Sine is positive. Sine is positive up, so it's got to be up here. Okay, so we draw our right triangle in there. Tangent's negative, so it's in 2 or 4. It's got to be positive for sine, though, so it's got to be in 2. Okay, so tangent is opposite over adjacent. Opposite is 1. Adjacent is 3. One of them has to have the negative. It's got to be negative on the what? The 1 or the 3? 3, because it's to the left. 1 can't be negative because it's going up. So the negative goes on the 3. We got to find out what the hypotenuse is. So 1 squared plus negative 3 squared. This is not a special triangle. Equals x squared. 1 squared is 1. Negative 3 squared is 9 is x squared. 10 is x squared. So x equals radical 10. It's positive radical 10. Hypotenuse is always positive. And then we write down our 6 trig functions. This is the last type of problem we're going to do in this section. Cosine, a lot of writing in this. Cotangent, secant, and cosecant. All right, we knew tangent was negative 1/3, so we knew cotangent is negative 3. That's the easiest one. Sine is opposite 1 over hypotenuse radical 10. 1 over radical 10. Times radical 10, you're going to get radical 10 over 10. Let's find cosecant. Flip 1 over radical 10, you get radical 10 over 1, which is just radical 10. Then cosine is adjacent, negative 3 over hypotenuse radical 10. Times radical 10, you're going to get negative 3 radical 10 over 10. Flip negative 3 over radical 10, you're going to get radical 10 over negative 3. Any question on these? Okay, if you look at the next section of problems, they talk about even and odd properties to find the exact values, okay? Now, I want to make sure you understand. You could do this way, and what I mean is this. When you look at number 59, it says the sign of negative 60. Now, you might just say, I'm just going to use my unit circle. And you could do that. You could find that. I mean, you don't see negative 60 degrees written on your unit circle anywhere. But if 60 degrees is right here, negative 60 would be right there. You would look actually at the 300. It's labeled 300, okay? What you need to understand is going 300 degrees this way is the same as going negative 60 the opposite way. You end up in the same spot, okay? And the answer to that would be, what is that, negative radical 3 over 2, I'm guessing it is? Okay? Yeah, that's right. Now, you could do that, but, okay, on your first test that we take, not quiz, we took a quiz yesterday, but our first test, I'm not going to ask you questions like that where you can use unit circle, okay? They're very likely going to be true or false questions, okay? It's going to be true or false. Well, you'll see once I explain these, okay? You guys got to help me out here. I'm trying to remember from Algebra 2. Did we ever, I thought we did, talk about, just, you may have forgotten them, even and odd functions. Did we ever talk about those in Algebra 2? Does that sound even familiar or not? No, I don't know if we did. That might have been something that we didn't hit because of the lockdown. Okay, I will just watch for a few minutes here, okay? I wouldn't copy any of this down yet. We got to talk about even functions and odd functions, okay? I think that we did talk about it. I think we didn't spend a lot of time on it, but I think we did. Well, we'll see. The easiest even function to talk about, and we're talking algebra right now. We're doing algebra 2. We're not doing trig right now, okay? Is y equals x squared. That's an even function, okay? And I want to show you why it's an even function. If I was to plug in 5 squared is 25. If I plug in negative 5, we get 25. If I was to plug in 8 squared is 64. If I plug in negative 8 is 64. Okay? If I was to plug in 3 squared is 9. If I plug in negative 3, you get positive 9. The reason why it's an even function means when you plug in a number and you plug in its opposite, what do you get? Heard somebody say it, I think. You get the same thing. You get the same thing. That's an even function, okay? If I was to plug in 84.7, I have no idea what 84.7 squared is, but I know when I plug in negative 84.7, I'm going to get the same thing. Like another good example. Your brothers, your youngest brothers. I have no idea what their birthday is, but I know whatever one birthday is, the other one has the same birthday. Okay, and you could say, well, one of them could have been right before midnight, one right after midnight, whatever, okay? Twins have the same birthday generally, okay? So again, I have no idea when their birthday is, but I know it's the same. That's what the even function is. When you plug in a number and you plug in its opposite, you get the same thing. You get the exact same thing, okay? An odd function, the easiest odd function is y equals x to the third, okay? If I was to plug in 2 to the third, 2 times 2 times 2, be careful, it's not 6, it's 8. 2 times 2 is 4, times 2 is 8. If I plug in negative 2, do I get the same answer? You get what? Negative 8. You don't get the same answer, you get a relationship though, you get the, not the reciprocal, opposite. You get the opposite, negative 8. If I was to plug in 5 cubed, 5 times 5 times 5 is 125. If I plug in negative 5, you get negative 125, okay? An even function means when you plug in a number and its opposite, you get the same thing. When you have an odd function, when you plug in a number and its opposite, you don't get the same thing. You don't just get something different, you get the opposite, okay? Now just so you realize, does this look familiar? We didn't do this in algebra 2? I swore we, no? Okay. All right. So, just so you understand, a lot of students think, so functions are either even or odd. No. Most functions are neither one. Neither one, okay? If I give you this right here, y equals 3x plus 2. Is that even, or is it odd, or is it neither? Well, let's throw a number in there. Let's plug in 10. If I plug in 10, 3 times 2 is 10, plus 2 is 32. Now I'm going to plug in negative 10. 3 times negative 10 is negative 30. Negative 30 plus 2 is negative 28. Is it even? No, because they're not the same. Is it odd? No, because they're not opposites, okay? You're going, well, these are opposites. The result has to be opposite, okay? That's neither even nor odd. Neither one, okay? So, most functions are neither, but some are even and some are odd. Now we need to relate that to trig functions, okay? We've got to relate that to trig functions. That was just algebra stuff, okay? So, I would just watch this. If I gave you sine, and I'm giving you guys the opportunity to really impress me here, okay? And if you can't, it's okay. Is the sine function an even function, or is it an odd function, or is it neither, okay? Now, just so you understand, we're not proving anything, okay? We're not going to prove it, but it's kind of like doing this. I'm going to prove everybody in here had Algebra 2 with me last year, okay? I'm going to prove it. Did you have Algebra 2 with me last year? Okay. Did you have Algebra 2 with me last year? Did you have Algebra 2 with me last year? Did you? So, I proved it, right? No, I didn't. How could I have disproven it? Huh? No, she was in Algebra. No, that was 2 years ago, wasn't it? That's right. Or I was thinking Jonathan. Jonathan didn't have Algebra 2 with me last year, okay? So just so you understand, when you prove something, It's got to be true for everything, okay? We're not going to prove it, but you're going to see why it is even, or it is odd, or it is neither, okay? Or you have that, hopefully you have a chance to impress me on this. If I gave you, it says the sine of negative 60 degrees, okay? What I want to know, is that the same as the sine of positive 60 degrees? Is that true? Why do you shake your head? I'm not saying you're right or wrong, or are you just moving your head?
No, because like you go up.
Why are the signs different? You're right, they're not. Yeah. Is there a relationship though? What? They're not the same.
Opposite.
They're opposites. Okay? You went up, you actually went up radical 3 over 2. How far did you go down? Negative radical 3 over 2. So what is a sine? Sine even, odd, or neither? It's an odd function. Sine's an odd function. Okay? Again, I wasn't writing this down yet. How about this? Is the cosine of negative 60 the same as the cosine of positive 60? Be careful on this one. Cosine. Is the cosine? Here's 60 degrees. Now, Meerkat says, she shook his head the first time. He said, no, you went up on this one, you went down on this one. Are they the same or not? Is that a true statement? The cosine of negative 60 the same as cosine of positive 60 or not?
It's even, okay?
Why do you say that?
Because it's both a half.
Okay, but let's just say you didn't.
Yeah, but you're going. If you can go left, you can go left.
Well, but hang on a second here.
It's to the right, they're both in the right.
I want to make sure. Hang on. Time out here. Okay. When I give you y equals x squared, I plugged in 5. I got 25. Let's just say I plugged in 6, and I got 36. Did I prove that it was either even or odd or neither? No, I didn't. I was supposed to plug in a number, and then I was supposed to plug in what? The opposite, okay? The opposite. I was supposed to plug in the opposite, okay? So I plugged in negative 60 and positive 60. Here's 60 degrees, here's negative 60 degrees. Are the cosines the same?
Yes.
Why? He said on sine that it was odd because they went up a certain amount and down the same amount. What are you going to say?
They both were the same amount.
You got to use one more word. You're leaving out a word. Same amount. They went the same amount. What?
Right.
Right. Good. He said they went the same amount up and down. Those were opposites. They went the same amount to the right. Now, if you're sitting there going, yeah, but this one's going up and down. Cosine's the what value? The x value. X was left and right. Don't think up and down. It's left and right. So cosine is an even function. Cosine's an even function. Okay? All right. Next one. Let's look at tangent. Let's do the tangent of, just say 10 degrees. That way you can't use unit circle. That's good that you use unit circle, but I don't want you using unit circle on this one, okay? Is the tangent of 10 degrees the same as the tangent of negative 10 degrees? Okay, well, here's 10 degrees. Here's negative 10 degrees. Our tangent's going to be, now you got to be careful, okay? Cosine you say left and right, sine you say up and down. Tangent you can't really say that for tangent, okay? First off, you should be able to tell me, are they going to be the same? You actually can look at your unit circles if you want to for a second, even though 10's not on there.
It's going to be opposite.
Why do you say opposite?
Because quadrant 1 and 3 are the same, while quadrant 2 and 4 are the same.
Be careful, you're leaving out a key word. You're going too far, okay? The same what?
Value. Like, no, because like if 45 degrees and quadrant 1 is 1, for the tangent is 1, while quadrant 3 is also 1. But
Okay.
2 and 4 is negative, so it's the opposite.
Opposite what? You're still leaving out one little word. One little important word though. Opposite what? Not reciprocal.
No. Opposite numbers.
Not up. You're right, and they are. You're right. When you keep saying 45 degrees, but what's the tangent of 10 degrees? It's okay. Say it. I don't know either. I don't know what it is. I know it's what kind of a number though? It's in quadrant 1. Positive. What kind of number is this? Negative. Okay. A negative. They have opposite signs. So, this is where it gets confusing in trig class. Opposite. S-I-G-N signs, not opposite signs, S-I-N. You guys know the difference, what I'm saying here? Okay, they have opposite signs. Now, I totally agree with you guys that, this is definitely a positive tangent, this is definitely a negative tangent. But you still don't know what it is, neither do I, okay? They are total opposites, okay? When you just said that one's positive, one's negative, you gotta do better than that, okay?
So if it was 10 degrees and 190, it would be same.
Yes. Okay, yes, exactly, because in that one, that has nothing to do with even and odd functions, that's because the period of tangent is 180 degrees anyhow, okay? Remember when I talked about 70 days from now, it's a, what is it, Thursday? So same with tangent. Sine, you gotta go all the way around, cosine all the way around, tangent, you only go halfway around, okay? But, so tangent of 10 and tangent of negative 10, this one's positive, this one's negative, and they are the exact opposites of it. So tangent would be an, not neither, geez, odd, okay? So don't write any of this down. See if you guys can figure this one out. And if you can't, it's really, really, really okay, all right? And this is a confusing, this section would be really simple for me to just say, oh, these are even, these are odd, go with it. Just like the unit circle, I could have just said, oh, here it is, know it, but I want you to understand it. What do you think cotangent is? And if you can get this, you'll fill in the other two really fast. Cotangent, secant, and cosecant. Do you think cotangent is even, odd, or neither? And I want to know reasons why you think it's either even or odd or neither. Any guesses? What's that? Why?
Because it's just the, I think we were saying inverse or reciprocal.
Yep, but it's
Is a reciprocal of tangent.
in tangents.
Tangent's odd.
Okay. What's secant, even or odd?
Secant?
Secant is even. Why? Because what's what? Because cosine's even. What's cosecant? Odd. Why? Sine's odd. Okay. So cotangent is also odd. Secant is also even. Cosecant is also odd. Okay. So here's what I want you to put down on the back of unit circle. Label it even and odd functions. Sine, cosine, tangent, cotangent, secant, cosecant. You just do that. I'm going to circle cosine and secant, they're odd. The other four I'm going to leave alone. What do you think the other four are? Whoa, 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 whoa. Don't write that down. Don't put odd. Put even. What are the four that I didn't circle? Odd. Okay? So, all that, the last 10 minutes or so that I've been talking, we can summarize that cosine and secant are even functions, and sine, tangent, cotangent, and cosecant are odd functions. Now, what I'm looking for, and again, when you're doing the assignment, you could use the unit circle. There's nothing, I'm not going to stop you. You can do that, but when we have our next test, I don't know when it'll be, probably a few weeks, I don't know exactly when, I'm going to ask you a question like this. True or false? The sine of negative 17 degrees equals the sine of 17 degrees. True or false? The sine of negative 17 degrees is the same as the sine of positive 17 degrees. What do you guys say, yes or no? Now, you got to be getting, before you go any further, before you even answer that, a lot of students will go, you know, they can't be right because one's 17, one's negative 17. Let's go back to algebra. True or false? 5 squared is the same as negative 5 in parentheses squared. True or false? I mean, you might, well, that's got a negative on it. Is this a true statement?
It's times itself.
So is that true or not? Yes, it is. That's a true statement, okay? That is a true statement, even though that's a negative right there. So that's a negative, that's a positive. Some students go, oh, they gotta be different, they gotta be different. I'm not saying they are different or they're not different. What do you guys think? Is a sine of negative 7, and if you have a hard time, you can draw a picture. Here's 17 degrees, here's negative 17
Same
degrees.
value, different signs.
Huh?
Same value, different signs.
So is that a true statement? Are these the exact, if you were to use a calculator, would this answer come out to be exactly that answer? No, it's not. They'd be what's? Not the same, they'd be opposites, okay? So what would you say, true or false? False. And I'm gonna ask you true or false and why, okay? Your why is a 2-word response. Why is that a false statement? Because sines, what kind of a function? Sine's odd. Sine's an odd function. And not odd like kooky and weird. It's not that kind of an odd, okay? So sine is an odd function. What if I gave you this question? True or false? Cosine of 39 degrees equals the cosine of negative 39 degrees. True or false?
True.
Why? 2 words. What's even?
Cosine's even.
Cosine's even. Okay? So you would say true. Why? Cosine is an even function. Okay? So to get some practice at it, here's what I would like you to do. Again, when we're doing problems like number 59, there's nothing stopping you from just using unit circle. But I'm going to give you angles like 58 degrees and stuff that you're not going to find on a unit circle. Okay? So, here's what I would like you to do. Actually, before we do this. If I gave you something like this, and you got to pay attention really good. This is very, 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 very quick, okay? It's very simple and very, very quick. Is that a true statement or not? How could I make it a true statement? There's a couple of ways. Don't blink. Now is it true? How about this? Now is it true?
Yep.
Sure. If you have opposites equal each other, the way you make a true statement is you change the sign on which side? Either one. Either one, okay? So why do I bring that up? Here's what I would like you to do. I would like you to rewrite this as a positive angle measure, okay? As a positive angle measure. So here's what we're going to do. We wrote down sine of negative 60 equals the sine of positive 60. All I did is I rewrote it, but I made the angle positive. It wasn't negative, I made it positive, okay? So every problem, I want you to make it a positive angle measure. Because where do you have negative angle measures written at on your unit circle? You don't. They're all positive. Everything is, okay? Is this a true statement? Is the sine of negative 60 the same as the sine of positive 60? No, they're not. They're opposites. So how do I make opposites the same? Don't blink. Now is it true? Yep. So here's what you do. You look for the sine of 60 on a unit circle. The sine of 60 is, what is that? Radical 3 over 2. So that makes it negative radical 3 over 2. Now if you're sitting there going, what the heck just happened here? It's okay, that's one problem. Just one problem, okay? There's a bunch of them here. Each one we do will get a little bit easier. Okay, so we have the tangent of negative 30. That's the problem. The first thing I would like you to do, yes sir?
So could you use that relationship to find, like, not the quadrant 1 and 4 relations, but like, if you had 60 degrees and 120?
Yeah, because they reflect over it. Yeah. Yep. It just took me a second. I just didn't register what you're saying, but yes, definitely. Okay, so first thing I want you to do is I want you to write that as the tangent of positive 30. Is that true? Is the tangent of negative 30 the same as the tangent of positive 30? No. Why? What's odd? Tangent's odd. They're not the same. They're opposites. Those are just like when I wrote up here, 5 equals negative 5. I said true or false. He said, no, that ain't true. They're opposites. Those are opposites. How do we make opposites the same? Put a negative either there or there. Okay, it doesn't matter. Okay, don't change leave the original problem. Well, this was the original problem set on your paper. Leave that alone. Okay, so we look up the tangent of 30 and whatever it says, make it negative. Okay, tangent of 30 was that root 3 over 3? Yeah. So negative root 3 over 3. Nope, it's not 65. Well, 63. The secant of negative 60. What's the next thing I'm going to write? Equals secant of what? True or false?
No, true.
Which is it? False or true?
That's
True, because it's even.
What's even? Secant's even. So where do I put the negative at? Nowhere. Don't put a negative anywhere, okay? So, hopefully you haven't forgotten this stuff. How are you going to find the secant of 60?
You flip cosine.
Okay, and how do you find, well, so you look for the cosine of 60. And what is a cosine of 60? You got your unit circles there.
1/2.
1/2. So what's the secant? 2 over 1, which is 2. $65, the sine of negative 90. And again, I've already said this, I want to say it again though. you could, there's nothing stopping you from doing this. You know that 90 is right here. So you know negative 90 is right here. The sign value is negative 1. We know the answer is going to be negative 1. We know that. It's going to be negative 1, okay? I'm more interested in the steps, though, because, again, I'm going to ask you questions that you can't use unit circle on. So rewrite this as a positive angle, sine of positive 90 degrees. Is that a true statement? The sign of negative 90 is the same as the sign of positive 90, yes or no? No. Sine's an odd function. They're opposites. So put a negative in front of it. Sine of 90 is 1. Put a negative in front of it, the answer is negative 1, just like we said it was going to be. Okay, the tangent of negative pi over 4 equals the tangent of positive pi over 4. Yes or no? Is tangent of negative pi over 4 same as the tangent of positive pi over 4? No. Tangent's an odd function. Okay? So, these are opposites. Whatever they are, they're opposites. So put a negative in front of it. If you haven't caught on to this, all we're doing is we're taking every single one of these problems has a negative angle measure. We're doing it with a positive angle measure. And there's a reason for it. Where do we have negative angle measures written at on a unit circle? Nowhere. They're all positive that we have written on there. Okay, we'll look at the tangent of pi over 4. What is that, 1? So it's negative 1. Is that negative we put in there? A few more, then we're done for today. 69. The cosine of negative pi over 4 equals the cosine of positive pi over 4. Where do I put the negative sign? Nowhere. Why? So those two values are the same. They're the same. Okay? Don't put a negative anywhere. Okay? So, we look at pi over 4. Cosine is radical 2 over 2. That's our answer. Oops. Sorry, people at home, you're missing most of this. There we go. All right, 3 more to go, then we're done for today. Tangent of negative pi. This one's sort of a tricky question. Is that the same as the tangent of positive pi? It kind of, I mean, it isn't, but it is. I mean, it's, you're supposed to say no because tangent is an odd function,
But they're both
okay?
undefined.
Ooh, careful, not
Isn't
undefined.
it the exit?
Yes, they're not undefined there.
Oh, no, the
They're
other.
undefined up here.
Yeah,
There's 0. So well, here's what we're gonna do. They're
Well, you
opposites.
can't have a negative 0, so.
Right, it's the opposite of 0, which is 0, okay? So we should put a negative right there, and then the tangent of pi is 0, the opposite of 0 is still 0. Yeah, there's no such thing as a negative or a positive 0. 0, 0. 2 more. 73. Cosecant of negative pi over 4 equals the cosecant of pi over 4. Or not. Is cosecant negative pi over 4 the same as the cosecant of positive pi over 4? No, cosecant's an odd function. They're opposites. So we put a negative in front of that. Okay, at pi over 4, to find cosecant, we look at sine and flip it. Sine is radical 2 over 2. Flip radical 2 over 2. It's just radical 2. And make sure you put the negative in front of it. One more of these. If you're sitting there going, I don't get these even and odd functions, I'll be right up front with you. We're never going to talk about, I won't say never, almost never going to talk about even and odd functions after this worksheet again, but it will be on your first test, okay? So if you never learn even and odd functions, can you pass this class? Yeah. Are you going to ace your first test? No. You're going to miss a few questions. Now it's kind of like, if you don't learn SOHCAHTOA, can you pass this class? Not really, okay? You've got to know SOHCAHTOA, you got to know the unit circle. So don't lose too much sleep over this, because there's some students that just really struggle with even and odd functions. Pi over 6 equals the secant of pi over 6. Yes or no?
Yes.
Yes, because secant is an even function. So we look at pi over 6 to find secant. How do we find secant? 2 words.
It's the reciprocal
Of what?
of
Cosine. So flip cosine. Reciprocal of cosine, 3 words, or just flip cosine. Okay, the cosine at pi over 6 was that root 3 over 2?
2, yeah.
So 2 over root 3 times root 3, you get 2 root 3 over 3. Okay. All right. So tomorrow we'll finish up 77 through 89. And I think those are a little easier than what we just did today. And then we'll have a work day on Tuesday. All right. We're done for today.